right. Sorry about the background noise. Okay. So greetings, YouTube. With our last session, we were working we were doing implicit differentiation, but we were doing the second derivative and we kind of got stuck. So I was like, okay, I had to pause for a moment, do a little bit of research and like, let's just try it again. We're going to try another one, right? So we want to differentiate this implicitly to find a second derivative. Now, and before all the implicit differentiation that we were doing, we did it where every time we took a derivative, we put either dy or dx and then use algebra to rearrange. So now I'm going to shift to a different technique where basically, since we're doing dy by dx, every time we take the derivative of y, we're going to put, every time we take the derivative of y, for me, it's a little bit easier. I'm going to put y prime. I started to do dy by dx, but every time we take the derivative of y, I'm going to put y prime. So in the past, we were doing dx and dy, and that's fine. But for this one, every time we take the derivative of y, I'm going to put y prime, right? So we essentially want to find y double prime. Okay. So we'll start here. 2y squared minus xy plus x squared equals 2, right? So now we're going to just take the derivative like normal, and every time we take the derivative of y, we're going to put y prime, right? So that the derivative of that first term becomes 4y times y prime, okay? And then for the second term, we need to use what? The product rule. So the first times the derivative of the second. So it's going to be x times the derivative of y is going to be y prime. So the first times the derivative of the second plus the second times the derivative of the first, which is just 1, right? Okay. And then the derivative of x squared is just 2x. And the derivative of 2 on the right is 0, right? So whenever we took the derivative of y, we put y prime. Let's expand this out and then basically group our terms of y prime on the left. Any term that does not have y prime, we're going to group it on the right. So then we got this 4y times y prime. We're going to have minus x times y prime minus y plus 2x equals 0. So if we use our algebra, and I'm going to go ahead and factor as well. On the left, we're going to have 4y minus x times y prime. And y prime is the same as dy by dx. And then the terms that don't have y prime, I'm going to move them to the right. So then we're going to get y minus 2x. So now we've isolated our y prime. We can divide both sides by that y prime. And so we get y prime equals, on top, it looks like we're going to have y minus 2x. And on bottom, we're going to have 4y minus x, right? So now we want to find the second derivative. Let me think about it. Okay. So now if we wanted to take the derivative of this, we need to use the quotient rule. Let's see. Yeah, I think that's as simple as we can get it, right? So then the quotient rule, so in other words, like we're saying, we're taking the derivative of that on both sides. And we're taking it on the right-hand side. Yeah, let's do it like this. So when we go to find d by dx of y prime, right? Here, do like this. So d by dx of u over v, right? Because we're using the quotient rule. So let me see, low d high, so the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, right? So then we need to identify our u and our v. So if our u is this y minus 2x and our v is this 4y minus x, then our u prime ends up being, let me see. So it looks like it's y prime minus 2, and our v prime ends up being 4 times y prime minus 1. Okay, so we want to use this. So now when we go to find d by dx of y prime, in other words, second derivative, that's going to give us, so now we got to use this formula that we just introduced. So our v is this 4y minus x, okay? Our u prime is, we got y prime minus 2, okay? Minus our u is this y minus 2x. Our v prime, it looks like it's 4 times y prime minus 1, okay? And then all over v squared, which is this 4y minus x quantity squared, right? So then to kind of bring this on home, the part that I kind of froze on during class, right now we go ahead and plug in the y prime, right? And it just seemed like it was a whole bunch of extra. Maybe it is, maybe it isn't, but I think that's what we need to do. Okay. So we need to substitute in y prime. So now we get that y double prime ends up being, we have this 4y minus x. Now y prime is, we got this y minus 2x over 4y minus x, okay, and then that's going to be minus 2. Then we got to say minus, we got this y minus 2x. We got, oh, we're missing, no, we're good there. So we got 4 times y prime, so 4 times y minus 2x over 4y minus x, okay, and then minus 1, kind of out of space. And then we still have over v squared, so 4y minus x quantity squared, okay? So now let's see, we need to like distribute and cancel. So for instance, if we distribute this guy, right, let's focus on that. If we distribute that, so our y double prime, they're gonna, the first set is gonna cancel, right? We got 4y minus x, so they're gonna cancel. So then we're just gonna be left with y minus 2x. And if we distribute there, we're gonna have minus 8y plus 2x, right? Because this times the first, they cancel. And then this times the second, you see it here. I'm gonna hold off on that negative for right now. And we need to FOIL, they cancel and that persists. Y minus 2x. Okay, that one is not as straightforward. Y minus, so 4y minus x. Oh, you know what? We could multiply, we can distribute, we can multiply by 1 in the form of 4y minus x, and that'll get rid of those fractions. So instead of distributing, I'm going to multiply by 1 in the form of 4y minus x on top and on bottom. All right, so let me back up. Let me get rid of this. So again, I'm multiplying by 1 in the form of 4y minus x on top and bottom. Now, if I distribute that on top, let me see. It looks like we get a 4y minus x squared, because there's 1 there. No, wait a minute. Maybe that won't help us. Let me go back to where we were. Hang on. Because if we distribute that, that cancels, that leaves that, and then that's there. We kept that minus. We don't get anything to cancel there. We can distribute the 4y minus x. Okay, so we need to do a few steps there. So I'm just gonna let this y minus 2x persist for right now. Minus, okay. So then it looks like if we distribute that 4 and get a common denominator, we're gonna have 4y, what is that, minus 8x over 4y minus x. And then the common denominator will be 4y minus x over 4y minus x, okay? So then we can combine those. The 4y's, it looks like they cancel, right? Because this is canceled by this, and then that becomes what, minus 7x, okay. Okay, we're almost there. Oh, and then this is still all over 4y minus x squared, okay? So then y minus 2x minus 8y, 2x, double negative is positive. We get a negative 7x on top. So on bottom, it looks like we still have our 4y minus x under negative 7x. Okay, so then at this point, it looks like the double negative becomes positive. And then now we can combine those numerators. Oh, and this is still over. Okay. Let's keep going. Okay. So then this just comes down. Can any of these combine? Oh, these two cancel. Negative 2x is canceled by that. Let's go ahead and address this guy as well. So then y minus 8y is a negative 7y. Okay. Now there, so it looks like we have 7xy minus 14x squared over 4y minus x, okay? And we got this 4y minus x squared. Okay, so now we can multiply by 1 in the form of 4y minus x over 4y. I think we're essentially there, right? So we're going to multiply by 1 in the form of, because we have a fraction within a fraction, so to get rid of that additional fraction, multiply by 1 in this form. Okay, let's see. I think we're there. Let's just do it and see what happens. So now on top, we have to distribute. Let's do this. We get negative 28y squared plus 7xy. Those two cancel, so then we get plus 7xy minus 14x squared. Okay, I'm pretty sure there's an easier way to go about this. And then on bottom, it looks like we get 4y minus x quantity cubed. Yeah, no wonder I got stuck on this, right? That looks like, is that a perfect square? Can we can factor out, what can we factor out? It looks like they all have a 7. We can factor out a negative 7. Okay, let's see if we can factor this out, because it feels like we can. If we factor out negative 7, what does that leave us with? 4y squared minus xy. So ultimately it's going to be what, minus 2xy plus 2x squared. So we can, 7 times 2 is 14, no. I guess we could have. Okay. Well, we'll just do it on another line. We can factor out the 2 again, because when we added those like terms, and then it looks like the bottom is persisting as this, which is fine. And then we can factor out one more 2. Man, that was an adventure. If we factor out 2, we'll get negative 14 times 2y squared minus xy plus x squared. Is this, no, it's not a perfect square trinomial. Over 4y minus x quantity cubed. Man, that's as far down as we could get it. We're gonna cross our fingers because we still need to submit this on Pearson. All right, so hopefully we got it. Yeah, yeah. Anyway, okay. That's about the best that we could do. Let me see. Because it's not, if that 2 were like a 4, then we would be there. But okay. So let's hop over to Pearson and submit this and see if it works. Let's go like this. And then I want this one kind of like that. Okay. Let's give this a go. Second derivative. 2y squared minus xy plus x. That's a good omen that we have that in there. I feel like there's an easier way. Now maybe we could have done a log somewhere. Let's yeah, okay. So let's submit this and see how do we do. Let's see if it works. Hopefully it works. We can stand by this. Okay. Negative 14 parentheses 2y squared, 2y squared. Oh, back up. 2y squared minus xy plus x squared. Okay, and then on bottom, let's do that thing. Bottom. Oh, this is so frustrating. I can't see it. I think I need to zoom out in order to be able to see it. One more. Okay. There you go. There it is. I'm like, come on. Then if I hit the X now. Okay. We got 4y minus x quantity cubed. Try again. Okay, 4y minus x quantity cubed. Let's see. This is what we get. It is promising that we got back to that original part. Okay, I'm just gonna hit enter. Wow. Yeah, I was not gonna get that. I don't know. I just blanked out on the during classes. It was the end of the day. I was thinking it was just gonna be light. You know, I low key want to do another one just to drive it home. Let me see. Let's try one more. I'm stepping out. We'll get a little bit cocky now. I probably should stop while I'm ahead, but you know, it's okay. Like that's how the point of this stuff is, you know, to learn. Okay, let's do another one. Not that I should be learning at my stage, but you know, it's okay. You still learn different stuff. Let's do one more. Is that too much? That is too much. Okay. So let's take this one and let's give this one a go. But yeah, I can see where the secondary, because I remember I just realized, like when I went to work with students, I was like, oh, I remember that kind of gave me a little bit of a hard time. But I knew I had figured it out, and I don't do this all the time. Like, okay, let me make adjust my changes. Okay, come on. We're just gonna do one more, just a good measure. Okay, we're gonna take this guy. Gotta figure out how to change the setting back. Like they did an update and then it kind of threw off my rhythm, but it's okay. All right, so let's do one more implicit differentiation for the second derivative, right? Again, they want us to find the second derivative. All right, I'll do this one. Like the previous one, I did it using in terms of y prime. This one I'm gonna do in terms of dy by dx, but not the way we did initially with implicit differentiation. I'm gonna use a technique where every time we take the derivative of y, I'm going to write dy by dx, right? Okay, so let's start by, instead of writing y prime. So let's start by getting a copy of the original. We got this 2x cubed minus 4y cubed equals 11, okay? So again, whenever we take a derivative of y, we're gonna write dy by dx, right? So now we just take the derivative like normal, the 3 comes down, that's gonna be a 6x squared. We don't need anything else there. The 3 comes down, that's gonna be minus 12y squared. Now we need to include dy by dx equals 0, right? So we can add that term with a dy on the other side, okay? So then we'll get 6x squared equals, I just did that so we can be working with positive values, 12y squared dy by dx. And then divide both sides by that 12y squared. So then ultimately, dy by dx ends up being x, we got 2y squared under x squared, because 6 divided by 12 is a half, right? We get something like this. But then we want the second derivative, right? So we need to find d by dx of both sides again, right? So we need to do d by dx of both sides, right? So, and it looks like we need to use the quotient rule, okay? So again, I'm gonna do, let me use purple for my color. So again, when we do d by dx of u over v, all right? When we do this, the quotient rule is the bottom times the derivative of the top plus the top times the derivative of the bottom over the bottom squared, okay? So our u, when we go to take this derivative again, our u is going to be what? X squared. And our v is going to be 2y squared, right? So that means our u prime is going to be 2x. And our v prime is going to be 4y dy by dx, right? Because again, whenever we do the derivative of y in this context, we need to include dy by dx, okay? So now, when we apply the second derivative on both sides, when we take the derivative again on both sides, on the left, we get the second derivative of y with respect to x. And on the right, the derivative of that, now we just apply this rule. So our v is going to be what? 2y squared. Our u prime is going to be 2x minus our u is going to be x squared. And our v prime is all of this 4y dy by dx, okay? And then our v squared is this 2y squared quantity squared, okay? So then also, so now that we got it here, we need to substitute in that dy by dx, we need to plug that back in, right? So now the second derivative of y with respect to x, let's go ahead and expand and simplify some stuff as well. So 2 times 2 is going to be 4xy squared. That's going to be minus 4x squared y times dy by dx. Oh, come on. Where's my dy by dx? Right there. So dy by dx is x squared over 2y squared. So this is x squared over 2y squared, okay? And then on bottom, if you square, that's going to be 4y to the 4, okay? All right. To get rid of the fractions, we can multiply by 1. So this is a complex fraction, basically, because you have a fraction within a fraction. We can multiply by 1 in the form of 2y squared over 2y squared, right? So let's do that. We're going to multiply by 1 in the form of 2y squared over 2y squared, right? And basically, we need to distribute that guy into the top, right? Okay, and on bottom. Okay. Ooh. Yeah, I'm about to wrap up. I'm not really teaching. I'm just doing a lecture. I am streaming. I'm almost done though. Give me like 2 minutes. She scared me. She opened the door and I was like, woo! On my stream. Oh man. And then the dog, just chaos. It was quiet and peaceful. And the dog is just now, because you know how my is. Okay. So the second derivative of y with respect to x ends up being, now if we distribute that guy, that gives us 8xy to the third. Let me see. I think those guys cancel, right? This is canceled by this guy. So we don't need it in the second part. So then what's left there, x to the 4, let me see, minus 4, looks like it's x to the 4y over 4 times 2 is 8 y. We're multiplying. We add the exponents, right? So y to the 6. So basically, what is it? It's 2y squared to the power of 3. So the 2 cubed is 8. Y squared to the power of 3. 3 times 2 is 6, right? Okay, I think we're okay there. Okay. And then we can simplify this. We have a greatest common factor. So let's simplify this a little bit further. So then we end up getting the second derivative of y with respect to x ends up being, we can factor out a 4 here. This is going to be the same as they all have a 4. They all have at least one y, and what's left is 2xy squared minus x to the 4 over 2y to the 5th. All right. And then these guys cancel. And this is what we get. Wow. 2xy squared minus x to the 4 over 2y to the 5th. Wow. Nope, that's not what I was trying to do. All right, this is what we got. We're going to cross our fingers. That was fun. Yeah, it totally caught me off guard because I hadn't done that in a minute. I mean, it's been a minute. So if you hadn't thought about that, and I usually don't look at these in advance, so that's part of the reason why, you know, I got so caught by that one, because I forgot about that with the second derivative of implicit differentiation, but that's okay. Let's submit this result and see how do we do. Okay, we're here. Can we just, no? Okay, that's okay. Right here. All right. Okay, and let's zoom out because I think that helped. Okay, that's fine. Let me get this to behave properly. There it is. Come on. It's so much just to type this in because I'm working on the iPad. You know, I don't think that this is really designed for it, but it's kind of working. Okay, here we go. All right, so the top we got 2. Let's now we got 2xy to the power 2xy squared minus x to the power 4, and then on bottom we got 2y to the power 5. Cross my fingers. Ah, okay. 2xy squared minus x to the 4. All right, let's see if we can find our error. Okay. So let's go back. Okay. Right here. Let's back up right here. Okay. 2x cubed minus 4y cubed equals 11, right? When you take the derivative, the 3 comes down. 6x squared, 12y squared, dy by dx equals 0. You can add and divide, right? When you divide, you get 6 over 12, so that's a half. X squared on top, y squared on bottom. Okay, so I feel good with that dy by dx. Then when you take the derivative again, we're doing the quotient rule. So The bottom times the root of the top. Oh, duh. Right here. I used the wrong formula. Just so focused. That one little thing. Oh my goodness. And that's way near the top, right? I put plus. That's supposed to be minus. Bottom times low D high minus high D low over low low, right? That's where we made our mistake. So the bottom times the root of the top minus the top times the root of the bottom over the bottom square. Okay, all of that stuff should be good. So, oh, but we put minus here. So we had a plus there, but we put our minus here. Okay. So our u should be x squared. Our v should be 2y squared. So then our u prime is 2x. Our v prime is 4y dy by dx. Okay. So then we apply it. Come on. So v, which is 2y squared, times u prime, which is 2x, minus u, which is x squared, times v prime, which is 4y dy by dx, over v squared, 2y squared squared, okay? So I feel good about this line, okay? So then we expand it, we got our 4xy squared, we got 4 minus 4x squared y times dy by dx, which is x squared over 2y squared. Okay. Okay. And then when you square that, 4y to the 4. Okay. Okay. That's okay. So then to get rid of that fraction, we multiply by the least common denominator of our fractions, right? So 2y squared. When you distribute that 2y squared, those guys cancel. And then over there, you get 4 times 2 is 8y to the third, 8xy to the third. Okay, that looks good. Oh, I found another mistake. We canceled the 2y squared. We forgot to, nope, we incorporated it. Because x squared times x squared is x to the 4. Right, so that becomes a negative 4x to the 4 times y. Okay, I feel good about that. And then 4 times 2 is 8. You add the exponents. 4 plus 2 is 6. Mm-hmm. 8y to the 6. Okay. Maybe we can just submit that result. If we divide everything by 4, that persists. That becomes a 2 and a 2. We divide everything by y squared. Oh, yeah, we got y squared. There's no y there. Oh, no. Yeah, I don't know what's wrong. Because that's y to the 5th. 2x squared, 2xy squared. Let me go check Pearson one more time. Get down. Get down. Thank you. That's how these things can be. If you divide by 4, 2x, what do we divide by? We divide by 4y. Factor out the 4y from all the times. So that's just x to the 4. Let me hop back over to Pearson. Yeah, I don't know. I couldn't find any mistakes. I wrote the formula wrong, but when I applied it properly. 2xy squared minus x to the 4 over 2y to the 5th. 2x1. Divide by 4. 8 divided by 4 is 2. We factored out 4y, so that becomes a y squared minus x to the 4. Can we factor it further? Darn. I can't see it. What are we missing? I feel like we're close too. I could just submit it. And I went through it. I went back through and justified each step. What about there? X squared, we said when we multiply the two, those canceled. You get minus 4x to the 4 times y. Yeah, that's there. That one, 2y squared. Oh, did I mess that up there? Okay, I think I may have found something there. Okay. So I felt like a pivotal point was here, right there, right, with the blue. I think that's where our mistake is. Okay, I think I found it. So if I go back, right here, this 2y. Now, when we multiply by this term, these guys cancel, so that's okay. But it's this one I think is where we're making a mistake. Is this one where I think we're making a mistake, right? So then 2y squared, 4 times 2 is 8. The x comes down. Y squared times y squared is y to the 4. Why am I writing y to the 3rd? I bet that's what it is. I hope that's what it is. Sometimes I forget this. But okay, so I'm doing this kind of intentionally because we need you. This is what it takes. Like you have to kind of go back and forth. If you don't get it right, then you got to figure out, okay, wait, where did I make my mistake? What am I missing? I'm just trying to. I made a mistake and I couldn't find the error, but I think I found it. So we're crossing our fingers so we can be done with this. Right? 8xy to the 4. Okay. So now with that change, let's see. Now with that change, so 4 times 2 is 8. The x persists. That's supposed to be y to the 4. I don't know why I was writing y to the 3rd. I was probably just rushing, excited. I'm almost done, right? So now we can factor out a 4. I think it's still 4y. So then that first one, if we factor out 4y, we're left with 2xy to the 3rd right here. So this 2 changes to a 3. Because 4 times 2 is 8. Y, okay. And then I think everything else might stay the same. The 4 is gone. The x to the 4 persists. The y is gone. On bottom becomes a 2. Y to the 5th. All right. So I think the only change that we have to make is change this 2 to a 3. Cross our fingers and hopefully we're golden. We found the mistake. You know, we thought we found it earlier, but we didn't make that mistake. So all we got to do is change that 2 to a 3. And otherwise, I think we get it, right here. Now it's like a matter of trying to get this to work. Change this 2 to a 3, cross your fingers. Oh Lord, that was fun. All right. I want to do another one, but I think I really need to stop while I'm here, right? I did the first one okay. The second one, it was one small mistake at the end, which was not bad. So, you know, anyway. So, but yeah, but what you just experienced, what we just experienced is like, that's what happens. You know, it's like you're going through and like, for instance, writing on this tablet, notice that I'm intentionally like keeping the space as clear and neat as possible, writing big, you know, taking my time. So that way, if I make a mistake, I can go back and find it. But if you write too small, it's like the smaller you write, the more borders are holding your head. So you want to write big and spaced out so that it's easier to see and track, right? And then I was like, okay, we made a mistake. So let's go back and take it line by line. And when you write it neat and organized and spaced out, it's a lot easier to kind of go line by line and digest it, right? So then we finally found at the end, for some reason, we put a 3 instead of a 4. And then when we made that adjustment, that was the only thing that we missed. So, but what we were doing was fine. That was an adventure, right? But that's how it goes. I just want you guys to see that it's not always clean. It's not always easy. This is why I do my course the way that I do it, with the remote asynchronous and only a 10% late penalty, right? I do that because I know, I acknowledge that some of these questions do get kind of nasty, right? And we're not mathematicians in that sense. And it's just like, the real intent of this for me, as for you all, was this just to be kind of like, I wanted to touch on these concepts, right? I didn't want to go heavy into like all the stuff that I know that Pearson does very easily. So because I know of the nature of Pearson, that's why I only do a 10% late penalty and unlimited attempts, right? So hopefully we were able to kind of get what we needed. I'm going to see if I can kind of edit that video and kind of replace it with this, or I'll just, link it some way or another, that video with this. Because I know it kind of fell apart at the end, but that's why I went back and did these two examples, right? All right, so that was an adventure. I hope you enjoyed the ride. And until we come back to do another one, and from one beautiful mind to another, enjoy the rest of your day. Okay, take care, guys. Peace.